we're asked to evaluate the second derivative of this parametric equation. And so we saw that dy dx of a parametric equation is dy derivative of y with respect to t divided by the derivative of x with respect to t. But remember, well, from our reading and from what we noted in a previous video, that this comes from the chain rule. Things work out. It's tempting to say that the second derivative is going to be, here, I'm just going to go ahead and put does not equal to right now, just so we know. It's not just the square of the numerator and the square of the denominator here. Okay, so this isn't true. It's not like we can square both sides because we're evaluating a derivative and we have a chain rule that happens. So there's derivations online. I can't remember off the top of my head if our textbook does it, but if you need the second derivative with respect to x using a parametric relationship, the chain rule applies and it makes the derivative a little bit different. I'm going to use shorthand notation here where prime just means the first derivative with respect to t. So this is the formula for the second derivative. And so it's the first derivative to the third power down here. Okay, so a little bit different than what we were expecting. So for this problem, the question gives it to us in a nice, easy to use format because it's kind of a big formula. It's easy to find the first derivative and the second derivative of these. And then, let's see, the first derivative of x is just t, second derivative of y is 2t, and the second derivative of x is 1, first derivative of y is t squared, so we could combine those in the numerator, and then down the denominator this is going to be t to the third. But we're supposed to evaluate at t equals 8, it just means you're supposed to plug 8 in here, so we could do that without having to simplify. This is 2t, this is 2t squared minus 1t squared. I guess it's easier to simplify. Yeah, so we get 1t squared over t to the third, and that's just 1 over t, right? So if we're supposed to evaluate at t equals 8, then it's easy. The second derivative is going to be 1 over 8.